right, guys. So at this point in time in our class, we've looked at distance, displacement, speed, velocity. We've calculated speed. We have looked at acceleration and acceleration calculations. We've looked at distance time graphs and calculated the speed and how an object's position changes with time. We've also looked at velocity time graphs and calculated acceleration from there and looked at how its velocity changes with time. So the last thing we're going to do is we are going to compare the distance time graph with the velocity time graph, just so you can see that they're not exactly the same thing. So let's get started. This is the note sheet that I have. So first thing, we always need to make sure that we read the axis. So this graph is asking you, what does the shape of the graph look like if a car is stopped on a distance time graph? So there's a couple of things that it could look like. The line could be down here. Okay, I'll get an orange marker. See if you can see that. The line could be ticking along the 0. All right. The line could also be up here. Now, a horizontal line on a distance time graph means that the object is stopped. My distance is not changing, but time is moving. That would mean it would be stopped. Okay? I am not moving. I have 0 speed. Now, on a velocity time graph, you're going to, again, have a horizontal line. However, the only time an object is stopped when it has a velocity time graph is when it has 0 meters per second. So it has 0 velocity, and there's only 1 point. So I've got a horizontal line at 0. So 0 meters per second, horizontal line. All right, this is at its starting position. On the distance time graph, it doesn't matter where it is on here. If the distance does not change, the object would be stopped. Okay? Going to a constant velocity. A constant velocity means I am on cruise control. So cruise control. On a distance time graph, any line that is a straight diagonal line. So straight diagonal line. Is going to be one that I would say would be a constant velocity. I could also add on it having a negative slope. Now remember, on this one, this line meant it was going away from its reference point. This meant it was going towards the reference point. So that's the difference between those two. Constant velocity. On a distance time graph or velocity time graph, how do you know if it has a constant velocity? Well, I'm going to have a horizontal line. And if I read my axis, I can make this 1 and this 2. Well, this says I'm going 2 meters a second, 2 meters a second, 2 meters a second, 2 meters a second, 2 meters a second. My velocity did not change. Okay, so you're going to have a horizontal line above 0. Okay, and we talked about going north versus south. I could even have one going below 0. All right, let's talk about speeding up. When we look at a distance time graph, speeding up means I have a curved line. So speeding up, curved line. And that curved line is going to increase its slope. Okay, could also draw it like this. Either way, curved lines. On a velocity time graph, how do you know if it's getting faster? Well, I would have a straight diagonal line. Notice my velocity is increasing. If my velocity is increasing, 1, 2, 3, 4, 5, I'm getting faster. 1 meter per second, 2 meters per second, 3 meters per second, 4 meters per second, 5 meters per second. So that is the difference. On a speed time or distance time graph, you have curved lines. On a velocity time graph, it's a straight line. And then slowing down. So if I'm speeding up on this one and I have a curved line, on a distance time graph and you're slowing down, you're still going to have a curved line, except it's just going to tail off like that. Okay, another way to draw it would be like, notice it's still increasing, but I didn't go up as fast and my slope changes. So it's a curved line that is less steep. And this line over here is a curved line that is more steep. Okay. Now on a distance or velocity time graph, if I am slowing down, it means that I have a negative slope. A negative slope. So this is going to be the line goes down, negative slope. On this one, the line goes up, positive slope. And if you read the axis, it tells you what's happening. So hopefully now you can see the difference between the two graphs. If you have any questions, please let me know.